In this problem, what we're going to be looking at is density. We're going to look at density of steel ball bearings. And the problem reads as such: a steel ball bearing with a circumference of 32.5 millimeters. So we have a circumference of 32.5 millimeters. And it has a mass, so the mass is 4.20 grams. What is the density of the steel in grams per cubic centimeter? And it tells us that the volume is 4/3 pi r cubed, and the circumference is going to be 2 pi r. So what we have to do is you want to find the volume of this sphere. In order to find the volume of the sphere, we need to know the radius. Well, we know that circumference is equal to 32.5 millimeters, and that is equal to 2 pi r. So what we can do here now is we can solve for r. So we have 32.5 millimeters. Divide that by 2 pi, and that's going to be equal to our r. And in this case, it's going to be equal to 5.17 millimeters. Is going to be the radius of the sphere. Now the volume is equal to 4/3 pi r cubed, and that's going to be, we could substitute our r into there, so we get 4/3 pi times the radius, which is 5.17 millimeters cubed, and that's going to be equal to, so the volume of this is 579.69 millimeters cubed. Now we need to find the density of this. And I'll do that, I'll use the blue marker for that. And density is equal to mass all over volume. Our mass is 4.20 grams divided by the volume, which is 579.69 cubic meters. We do this arithmetic, and what we'll end up getting is 7.245 times 10 to the negative 3 grams per cubic meter. However, the problem wants us to put it into grams per cubic centimeter. To do that, we have to do some conversions here. And I'll do the conversions in pink. So we have 7.245 times 10 to the negative 3 grams per cubic millimeter. Now you have to ask yourself, how many millimeters are there in a centimeter? Well, we know that there are 10 millimeters in 1 centimeter. But we're not entirely done yet. You see, we have this millimeters that's cubed. Here we've only got it to the first order. So we have to cube this entire conversion. Because when we cube this, we'll have a millimeters cubed per centimeter cubed, and that's what we want. And now these cubic millimeters will cancel, and we'll have cubic centimeters at the bottom. And this is going to be equal to 7.245 grams per cubic centimeter, which is the density of iron. If you have any questions on this problem or any other ones, feel free to let me know.